acceptance.
I love these animations where they say hacking code, access granted. I wish it was that easy. And yes, we're going to talk about security today, about Java and about serialization and deserialization. But first, I want to start with this. Space, the final frontier. That was the tagline of pretty much one of my favorite series in my childhood. Who has seen Star Trek: The Next Generation? Who of you is more of a Star Wars fan than a Star Trek fan? A few? Cool. Who is more like, I don't care if it shoots in space, it's fun? Yeah, I'm with you. This will not be a Star Wars versus Star Trek themed kind of session. However, I like Star Trek for a particular reason, because things in the series are already real, or it was a prediction that something they showed in that series became real, or, well, and hopefully things can be real. I mean, in this series there is an Earth and we travel to different planets. So I like that idea of things becoming real. However, if you look at some things in the series, things are pretty outdated. I mean, if you look at the computer that Spock is using here, and I give that to my son, he will be like, really, dude? My phone has more computational power than this box of lights. So some things are already outdated, however, they are still in space. There is, however, one thing that I hope that will come together and for once be there in real life, and that is teleportation. I wish it would be easy for me, living in the Netherlands, to go from Amsterdam to Krakow in just a blink of an eye, decomposing my body into a stream of data, send it over the air to somewhere else, and composing my body back here on stage. That would save a lot of air travel and painful delays. But however, if you look at this concept, we all are already using this concept. The concept is not new. And basically, we do this the same in data, with objects. Decomposing objects into a stream of data, send it over the air or over the network to somewhere else and composing it back to the original state. And that's what we're going to talk about today. How decomposition and composition works in Java, and how this is, well, how can I say it nicely? We're in Poland, I don't have to say it nicely. The root of all evil. Let's keep it to that. I am Brian. I am a Java champion. I work for a company called Sneak, and my official title is Staff Developer Advocate. I have no clue what that means. It probably means something. I used to code a lot, now I code a little and I email. Let's keep it to that. Do a bunch of stuff in the community, like I'm leading the Netherlands Java user group and the virtual Java user group. Yes, we were virtual before it was cool, and a bunch of other things. However, that is not important, but because we're going to talk about the gift that keeps on giving. And that might sound like Christmas to you all, but it's not. It keeps giving in the wrong way. It is about serialization and deserialization natively in Java. And you might be like, we're not using that, so we're fine. Watch me. I will show you, you probably are not. Who knows how serialization and deserialization works in Java? A few, not everybody. Well, I give you the short version. Serialization, you have an object. Whatever object it is, doesn't matter. We serialize it into a stream of bytes. And either we send it over the network to another place, or we might store it on disk. Right? Well, what is deserialization? Pretty much the other way around. We have this thing from the network, it comes in, we construct it back into its original state, and we can use it in our program. Well, that was all. Thanks for being at my TED Talk. No, of course not. Let's dive into how this works in Java, because if we look at how these things work in Java, or how the architects designed it, they designed it with a specific thing in mind. It needed to be easy for developers. you need to have joy in it to stay in the same context as Sven before me was talking about. It needs to be easy, not painful. So let's say I have this object. The only thing I need to do to make it serializable, to serialize and deserialize this, is implement serializable. That's all, done. And this thing, this value object, and has nothing to do with value objects in Loom, but I just called it a value object because it contains a value. It has two fields, a string value and a string side effect. And as you can see, is that in the constructor I set value to the specific field, and the side effect is set as a side effect in a constructor. So the constructor has logic in it. Okay, sure. So how do we serialize and deserialize? Oh yeah, pay attention of the constructor. The side effect is set as a part of the construction. That means you normally do not set the side effect yourself because it's a private variable. So let's serialize it. This is the easy part. I have as a reference, I have my object, very simple. And the only thing I have to do is pretty much this. If I want to serialize it and put it into a file. File output stream, object output stream. I write object, and I close the stuff. Right? Done. Stored on a file. Fine. This is also not the problem. The problem is actually the other way around. But let's first inspect this thing. So if I look at the file that I just created, I can basically read it. There is the package name, what kind of object it is, and what are the fields in my object. For instance, the value of this object was high. But also, the thing is that when deconstructing it, there's no such thing as checking if validation is true or if this is actually a real object. What I can do, because this object is part of my system, I can just intervene with it and change things to another value. Super easy. Because what happens is, if you deserialize things, some weird things happen. So I easily can change values from the serialized object. But if I deserialize this object, and for reference, we have this object again, I need to do a few things. 3 lines, basically. File input stream, object input stream, and then something weird. In.read object. And I cast that to a value object. Okay, let's look closely at this one. What happens here? First of all, there is no such checking with a checksum if I change the raw object if it's still valid or not. So by interfering with that object manually, or by doing a man-in-the-middle attack, or by grasping that object or feed you something that you expect is something but it's not, I can already change the state of an object, because reflectively, these fields will be set into the original object. Secondly, what you see is the object returns in the state it was originally in, which is fine, but it will bypass the constructor. So say we have something in the constructor like validating if an object is actually what it should be in a valid state, we are bypassing that with deserialization. That means setting the side effect is not done by the constructor, but is reflectively injected into the object. Okay, this is all fine, but we now know that the constructor is not called, so everything I do there to make sure that the object is in a certain state is not happening. So potentially, by changing the raw object, I can already feed you disinformation. Okay. Then look at that last line, value object in.read object. What happens if actually the thing that we're reading is not a value object? Who knows that? Who has an idea what happens? What kind of exception do I get? Scream it, because I cannot see all the hands. I see a few hands. Exactly, class cast exception. But remember, class cast exception means that the object is already in memory. And then we're trying to cast it to this value object. And then it goes wrong. Hold that thought, because it's already in memory. Now, sure, this is weird that you can change things and we bypass any algorithm or any safety protocols that we do in our constructor, but that's not yet the bad thing. Let's talk about gadgets. And I'm not looking at this inspector gadget, but actually gadgets. Who of you knows what a gadget class is, or a gadget is? 1, 2, 3 hands. Okay. A gadget is something that is a class that if you put it into memory, if you make an instance of it, it has a side effect. By default, it has a side effect, for instance, by calling something off, creating a function, doing something that is not actually part of creating only, but does something different with it. And I created a gadget, a simplified gadget over here. It is serializable. So the thing is what it does here, I overrode that read object. And remember the previous slide that is an in.read object? This is possible. You can override a private final void for whatever reason. And what you see here is that the field in this gadget is a runnable command. What happens if I deserialize this? As a side effect, I actually run whatever is the command, because it's a runnable. So again, what does this mean if we go back to these 3 lines? The last line said in.read object, and then we already said it would be giving you a class cast exception. But what happened to the command? Did it run or did it not run? It did run, and I will show you. So I have an application over here. I have that gadget, I have that available, and what I'm doing here is I'm creating that gadget, and maybe I need to zoom this in. I'm creating a gadget, and as a command, I give it env, basically showing the environment variables on my local machine. And I will serialize this gadget to the file gadget.ser, right? Serialization is basically the lines that I showed you already, but now in a function. Cool, let's run this. Ta-da, yeah, it runs, fine. Let's go. And you will see that gadget.ser is created. Let's now deserialize it. And what we see when we deserialize things, we expect a value object, but it's not. It's a gadget called gadget. So when I'm running this, as part, yes, we have the class cast exception, right? We'll see that. Hopefully this is big enough. We see that we have the class cast exception, but as a side effect, the thing is already in memory, so already the harm is already done. Because it is in memory, it's an object, and an object is runnable. I now have, in my output, I have my environment variables. Hopefully I didn't put my GitHub key in there. No, not. Would be fun if we did, so you could live hack me. Anyway, that is the basics of the problem. The thing is, we're just taking something in. We don't know what it is. We put it in memory, and then we're like, is it actually what we think it is? No, it's not class cast exception, but the harm is already done. So thinking about that, then you will probably say like, yeah, sure, but nobody has this gadget class in his class path, right? Who would create such a thing? Well, me. For demo purposes. But do you know how many classes there are in your application? How many classes are there available on the class path? Well, let me ask you a different story. How many dependencies do you have in your application? Oh, ow, yes, that's a lot, right? Spring Boot Starter. Oh, wait, Spring Boot Starter Web as well. I have two dependencies, but yeah, you know, dependencies bringing in dependencies, bringing in dependencies. I did a tweet once, as in I created a 4-line Spring Boot endpoint saying hello world, and I had over, I think, 400,000 lines of code that were actually in my application. That means because you're importing so many packages, and every package has multiple classes, all these classes are available in the class path. So think about it, that this is just a single line chain. But normally, this will happen like this. I just need one class that overrides that read object and put something in there, and maybe put something else in there, and chain objects together into a payload that in the end, something would actually execute code. It will probably not be a single hit like I did here before, but you can imagine with the amount of classes that you have in your system, from all the different packages plus the JDK or your Java runtime, if I combine all these things, it might be possible to create such a chain. So, first of all, you would say, yeah, but who would override the read value object? Check the implementation of HashMap. Just do. HashMap overrides the read value object thing already. So there I've got my entry point. Now I just have to put things in the HashMap to make sure that if it's getting deserialized, that it actually blows up in your face. Sure, Brian. That's all fine, but finding such a gadget chain is hard. Super hard, so whoever does that. Well, let's get you into a tool, and that tool is strictly for educational purposes. We call Why So Serial. This actually exists. It is a GitHub repository. And what the folks at Why So Serial did is look at known existing gadget chains that could actually turn into arbitrary code executions. They made up a few of them. This is partially the list. And it can be as simple as just importing one specific library, like Commons Collections 3.1, or it can be a combo of particularly different libraries. Like here, it says something like JSON lib, Spring AOP, and a bunch of other things that didn't fit on the screen anymore. What they did for us, thank God, is that they created these payloads for me. So connecting the dots already, that we have that chain with an entry point and a sink, as we call it. Or I should do the entry point and a sink. I'm going to use this one, the Commons Collections 5. Well, basically based on Commons Collection 3.1, but the 5th version of this hack that they're creating. So let's do this. Yes, we've seen this. This is all fine. All right. What I'm doing here in this very, very simple demo, I am doing something with a lazy map, just to make sure that Commons Collections 3.1 that I have as part of my POM file is loaded into memory. Because normally, if you use such a library, you actually use it. So I know it's there in memory. I don't have to do some real weird trickery. Then I'm going to read a payload.scr. Well, let's create that payload first. And I have a hack over here that, yes, I need this one. I have the binary of Why So Serial, and I will enlarge it in a second, don't worry. Terminal. Cool, let's enlarge this. And what I'm going to do is I'm going to call this version of Why So Serial 0.06, Commons Collection 5, I told you that, and I'm going to say touch hello, no, not hello people, let's make it specific. Hello Devoxx. And I send it to a file called payload.scr. Right? Okay, apparently this is done. Let me check. Payload.scr, just created, just a few seconds ago. Fine. So I have it. I have this payload. Now let's go back to my demo application. And what happens here is I'm actually loading the file, and I'm deserializing, and again, I expect it to be a value object. Well, we already know things happen, so let's try this. Let's run. Okay, class cast exception, as we expected, but let's see what is actually in our system. So go here, and as you can see, hello Devoxx is created. So okay, now I just created one file. Ooh, interesting. But it also means I can execute terminal commands by just giving you the wrong payload, and you expect it to be something completely different, but because you have a library, I can create such a chain. This also means I can create a file with some content, come back tomorrow, execute that content, and there runs my Bitcoin miner on your application because you accepted serialized payloads from strangers. Oops. Also think about this. If I can do this, creating a file, I might also be possible to initiate contact from your machine back to my machine and do a reverse shell attack by listening to the port that you're going to connect to and actually take over your machine. Basically, arbitrary code execution is horrible. And this is because the way deserialization in Java works by default. So, okay, fine. But I don't have Commons Collection 3.1 in my library. So how bad is it? Well, I also already asked you how many libraries you have in your system. And it's quite a lot, probably. I stole this slide from Ian Haken, a researcher at Netflix. And he did a presentation at Black Hat 2018 about deserialization problems in Netflix. And what they did, they created a scanner to go over their applications and see if there were deserialization chains available there that could be exploited. This was the result from one of their applications, the so-called Web App 2. And what you can see is it's a chain with basically 12 classes, and it consists of classes from 6 different libraries plus the Java runtime environment, because all these classes were available in their system, so it was possible to create that. How many of you create software that they publicly publish on, for instance, GitHub or Bitbucket? Some people do not like, no, don't say that. A few of you. So think about it, like nowadays in some countries, even governments need to open up their software and show them what actually is in there by publishing it on GitHub or even making it open source to a certain extent. Now I just need to bribe Ian to have his scanner on, and I can see if there are classes available that can create such a gadget chain available. But okay, sure. Who uses actually serialization and deserialization actively in their application? Still a few. Who accepts payload from possibly unknown entities outside of their system? A few, yeah. So the rest of you are like, fine, I'm free, let's go and have a beer. Not really, because maybe you're not using it, but maybe one of your libraries is using it. Let me ask you a simple question. Where were you on December 10th, 2021? Oh God, yes, that one. Yes, I know, it's getting boring, I understand. But yes, log4shell. I'm not going over the whole problem, but log4shell essentially was a deserialization problem. And we didn't know about it. It was there in this library since 2013, early 2014, depends on if you look at the pull request or the merge. But it was there. It was discovered in 2021. Well, guess what? December 10th, I was trying to go on holiday. That didn't happen. No, we found out that 60% of our customers within Sneak had log4shell as a transitive dependency, so they didn't even know they had the problem until we pointed to them. Over 800,000 attacks happened in the first 72 hours. And 17,000 Java packages were instantly marked as vulnerable because they were using log4j as transitive dependency. For those who don't know what the hack is about, I will briefly tell you this just to understand what the problem is. So this is a drawing that is not made by my son, but actually a coworker. I make fun of him all day, but still, it actually explains what the problem is. So the problem was, say I'm logging something. I know that something is logged, like here. For instance, an error log for whatever. Say I'm logging in with my username and password, and the password is wrong. You probably say, user Brian failed to log in, attempt 1, something like that. So I know that username is logged. For some reason, I could do a JNDI request, so we'll look up to a class and actually retrieve that class, because that's what JNDI does, and use the LDAP protocol. Okay, so if I own the LDAP server, I can point you to a precompiled class, for instance, a class that I show you over here. I have a server running, I have a precompiled class, and if that class comes into your system, it has a side effect by executing code. Basically, serialization. Because if I do something like this, I implement the object factory in my evil class that I bring in to you, and in this case I say, hey, open up the calculator on my Mac. This works instantly. Let me show you. Let's go here, let's spin up an application. Oh, demo gods, please bear with me. Spring Boot, always nice, because then I have a ton of libraries. And let me spin up my server that serves that LDAP server and the HTTP class. All right, let's put that on the side. Let's put this one on the other side. And just to show you, I am using an old version of Java. Java 8, but built 111. And I come back to that, why this is important. So, localhost 8081, I guess. Yes. So if I say, no, type your name right, dude. What's wrong with you? So if I do something like this, I know this is the wrong password, but what we see in the end, underneath here, you will see that my username is printed. So we know that we can misuse this. I have my LDAP running and my HTTP server with the precompiled evil class with that starts up my calculator. I have that running. So let's do the right call. Let's call JNDI lookup to LDAP localhost, in this case on port 9999, where my 9999, yeah, that's where LDAP is running, /evil. Give it a wrong password, and if I sign up on here, boop, as a side effect, something happens. That was basically what you saw everywhere. Hey, this is the log4shell problem. It took me about, I think, to find out how this works and actually make an exploit, took me about 30 minutes on December 10th. So it was, if you know what to look for, it was pretty scary. However, there are a few different things. Let me close this one and let me open the same application. Docker compose up. Yep. The problem was that in the initial version, and this is a blog post I wrote myself, we thought that if you're only on older builds of Java, you have a problem. Because at older builds of Java, the parameter trust URL codebase was set by default to true. Which means that you pretty much say whatever is there on the other server, I don't have it here, but no, I don't care, I trust it. Well, that was basically the problem. I didn't have that evil class in my class path. Newer versions of Java, so from Java 8, 191 and up, and everything above 11.0.1, had that parameter set to false, so you're not technically vulnerable to this thing anymore. Or are you? Well, wait. I said, by default, this is actually a deserialization problem. So what if I change my server a tiny little bit? I have my server over here. And what I did, instead of creating that evil.class and precompiled it, I went to ysoserial and took the code from the Commons Collection 3.1 problem. And basically what they're doing in Commons Collection, there's a constant transformer, and with the invoke transformer, I can get a method I basically get the runtime. I just copy paste it from their repository and actually execute it. So basically what you're saying is, hey, you have the runtime class, execute whatever I put into you. And now serve it to you as a Java serialized payload. Okay, let's do that. But instead of just doing that, just make it a little more intense, because, hey, starting up a calculator, boo-hoo, it's interesting when you need to calculate things, but it's not really fun. So let's see what I did here. I hopefully can find my original code. La-di-da, la-di-da. HTTP server is running. Yes, it's already. Oh yeah. So I'm calling that commons, as in I'm using the payload from Commons Collections 3.1 that I also have in this application. And now I'm calling this string from a Docker container back to my local host, which basically said, hey, try to open a connection to port 9001. And for all of you that know Dragon Ball Z, because it's over 9,000. Anyway, what I'm trying to do here is actually execute that code, but before it's getting interesting, let me use netcat. Netcat minus LVP and listen to port 9001. So it is now listening. Fine. Cool, let me do this again, and let me now connect to, this is the wrong one. Let me now connect to this one. So I'm connecting to, this is running in a Docker container, and this has a newer version of Java. If you wanna, I can look it for you, it's 3 something. Going to the logs, whatever, it's somewhere here. Never mind, it's a newer version of Java, so the old thing is not vulnerable anymore. But I'm doing that new thing. I'm using Commons Collection and that gadget chain to actually execute it on a very new version of Java 8. Listening to port 9001, give it a wrong password, sign in, and oops, I'm in. Oh yeah, this runs in a Docker container. What is the default user for a Docker container? Root. So that means from my remote system, which is now on my local system as a Docker container, but it could be on Heroku, on AWS, on whatever, I am now in from my local machine, and I have root access. This is getting fun. And just because you were using log4shell and Java's deserialization is a mess. So even if you're using older versions of, or if you're using log4j, the older version, with a newer version of Java, you're still vulnerable if there is a possible gadget chain available in your system. And we saw it's quite possible that there is. You just have to find them. Anyway, Java serialization is kind of messy, and that's why they are trying to get rid of that. But hey, what about records in Java 17? Well, basically 16. Doesn't that change everything? There was a message on the interwebs, in Twitter, that this will change serialization. A bit. This is a record. The only thing I did with the record, in this case, I overrode the constructor to have a side effect of printing something. Nothing else. Does the normal behavior. And I implement serializable. So what I did is the following. I created the record, and I'm serializing it, and then I'm deserializing it. Basically the same code that I showed you before, and I'm just printing things. What is the output if I do this? Just basic serialization and deserialization in the same routine. Well, this was the output. First of all, it says creating a to-value via the constructor, because that's literally the first line. Cool. Then I serialize. No weird things. Then I deserialize, and when deserializing, it says again, creating a to-value via the constructor. This means that records do use the constructor to recreate the file or recreate the object when deserializing. So that already solves a bunch of problems. The first problem I showed you that that maybe you have in your constructor some logic that tests if this is in the right state, if it's not in a state that you don't want to have it in your system whatsoever, is now fixed. But only for records, because we're still using in.read object. So all the other problems we still have. Unless everybody uses records, it's probably not. So yes, this is an improvement, but it's not the solution. What is the solution? What can we do? Well, first of all, try to avoid serialization. If you need to implement serializable because you depend on a domain model that somewhere says implement serializable, you can override the read object and give it an I/O exception. Because if people want to read that, boom, done. And it's better to have an exception than to actually have a problem, like remote code execution. But I saw already that some of you need to implement serializable, and maybe that's for a good reason. There are a few things that you can do. The thing is, you're loaded in memory before you cast it. So let's change that. For instance, by using the Apache Commons I/O library, it is possible, instead of using a normal object input stream, to use a validating object input stream. In this case, I can create an acceptance list of which classes I actually accept. So what it does, it pre-inspects the stream to see if that's there before it casts, before it gets into memory and casts it. So you don't have the problem of that you're getting classes in that you do not expect. This is already a great thing. But now I have to put in another library, and I already have so many. Also, in Java, there are updates that can help you. JEP 2.9.0 was introduced in Java 9. Who is still in Java 8? Oh, put that hand down. Nobody wants to see that. No, I'm kidding. I get it. I understand. But JEP 2.90 was introduced in Java 9. And in JEP 2.90, you see that in the middle part, you can create filters. And in this filter, you can create it in such a way that you either inspect for a certain object or for a certain class that you want to accept or you don't want to decline, or you want to look, for instance, the depth of a specific array. And you can mix and match these filters in such a way that you only accept what you need to accept. This is already great, but there was an improvement in JEP 4.1.5, and 4.1.5 was released in Java 17. The problem was that I could create these filters either by creating a parameter and tie it to the JVM, that was the global filter, or I can, like here, no, that's my wife calling. She knows that I am. No, darling. Oh, I need to sleep on the couch tomorrow, I guess. No, not kidding. Anyway, what I'm doing here, I am creating this filter specifically on an object input stream, or on a specific stream. The only thing what it does is, say I set something on the global level with a JVM parameter, and then I do this on a specific input stream, it overrides the other one, which is not good, because now I don't know if I set one on a global level. Maybe some of my libraries did override it, and I'm not sure which rule now is in place. So with JEP 4.15, you can set the filter factory. And basically what the filter factory does, don't look at the JEP and look at what it actually does, because I read it 14 times before I actually understood it. That says more about me than about you, I know. But still, what it does is you can create a function, you can give it a function to say like, hey, if a new filter comes in, how should I accept that? In this case, I say merge it in the obvious way, so both filters are still available. To show you that, I have, how many time do I have left? I've got enough left. Let me see where I have it. Yes. So let me enlarge this so you can actually read it. What I'm doing here in this application, I'm creating a gadget, and actually the outcome is not really important. And I set a filter here, right? I set a filter here on a global level. I can do it either in code or as a JVM parameter. And what I do as well, I set the serialization factory filter that basically says, hey, if there is a filter and a second filter, merge them. Over here, when I serialize the stuff, or when I deserialize the stuff, save deserialization, I again set a new filter. Allow filter, whatever, equals integer.class. It doesn't matter. But if I run this, what you will see is that the filter that I'm printing out at this point over here, I'm printing out the filter. Let me run this. You see that it is a merge of two filters. So actually, both filters are in place. If I would remove this, where is it? This set serial factory, and run it again, you will see that the last filter I put in overrode the global one, which is not what we wanted. So by using Java 17 and the set filter factory, it is possible to have both one in global state and one locally for a specific deserialization problem. This also means that if you're using libraries wherever and they use serialization, that still your global filter is in place, which was not the case with JEP 290. So this is an improvement that is actually very handy. If you want to read more about that, I wrote a blog post that actually explains it with demo code, etc., etc. I also will publish the slides, so don't worry. Oh yeah, probably half of you will be like, good thing that we're not using Java's serialization thing whatsoever. Who uses JSON? Hands, come on. I'm using JSON. Yes. And who uses JSON with, for instance, Jackson? Yeah, I thought so, right? Well, basically, this is also serialization and deserialization, but we call it marshalling. Basically, we have that object, and we create into a readable stream of data, a JSON string. And then we do it all the other way around and post it again. Well, Jackson is the most commonly used JSON marshalling and demarshalling library, or JSON serialization and deserialization library, because it's shipped to you with lovely, lovely Spring Boot. But there are also some quirks with that. No, it's not a real big problem, but it is. Look at this. Object mapper. And then I'm saying object mapper dot enable default typing. Who knows what default typing is? Whoever set default typing to true? I see one hand. Don't do this. By default, this is getting weird. By default, default typing is off. Keep it that way. Because what default typing does, it uses the inheritance chain. So basically, if I'm saying, hey, I am trying to deserialize a myPet.json file, and I'm not sure if my pet is a cat or a dog or something in between, but I know at least it's an animal. It can, with default typing, I can make sure that it's getting transitioned to an animal instead of the dog or the cat, so I can use inheritance. Makes sense. But what if I take this to the extreme? I have a person, and instead of the name is a string, it now is an object, which happens, unfortunately, a lot. This is a weird example because who would say object.name in the middle thing? Well, if I try to serialize the string below, my age is 37. Oh, I wish my age was 37. It's not anymore. And my name, this will be perfectly fine. But if you have a gadget or a gadget chain available in your system, I could do also something like this. Call the specific class and give it, in this case, I'm reusing that gadget that I showed you before, that simplified thing, and giving it a command. So I can use whatever gadget you have if you're subtracting to object. And you might think, yeah, who does that? Well, think of wrappers as ehcache. They can hold the ehcache wrapper object, can hold any object. So all these things are identified. And the lucky thing for Jackson is the maintainers of Jackson do a good job. Whenever they find such a gadget that can execute or can be potentially executing a gadget chain, they blacklist it or they block it actively. And by default, default typing is off. So if you're not touching that, don't also tell this to your colleagues, not doing that. It seems fun, but don't do it. You're basically not in trouble. However, all these gadget chains are identified, and that's why you will see such a list of problems with deserialization issues in Jackson, and this is only from 2022. March 2022 up down to January 2021. And there are a ton of them, because every time they find someone, they put it in that list and actively block it. So the Jackson folks are doing a good job, and they are well aware of what their defaults are. Lesson, don't put that default typing on. Exactly, that's what I said. Oh yeah, and update your libraries, because it might be that some of your libraries also use Jackson and they do enable default typing. Or who inspects all the code of all the libraries that they're using? That's what I'm saying. Who likes YAML? Really? There's not enough space for you, normally they would say, but that's a lame joke, I know. YAML. YAML has also an issue. Let me turn this one down. Stopping superheroes, that's great. And let me spin up this. This is exactly the same application, but now I can actually show what the problem is. Oh no, I don't need this one. I need the other one. Wait, stop. File, open project. Let me see if yes, this is the coffee shop I need. Good. So let me run my coffee shop application. La-di-da. It starts, great. Localhost, I think it's on 8082. Yes, so what I can do, it's a coffee shop and I can buy coffees or beers, which are even more important. I can log in as a user password's probably user because I'm lazy. Yes, works. No, don't change the password because it's a demo. Please don't. Again. See, it punishes me because having a bad password. All right. Yeah, it's fine. Stop. One of the things I can do, I have orders here, and I can export to YAML. Why would you do that? Because you can. Because YAML is yet another marshalling library, basically, or snake YAML that I'm using. This is how this YAML looks. Hey, as an order thing, fine, product name, all good, right? Nothing really special. But I'm using snake YAML, which is shipped to me with Spring Boot. And by the way, even in Spring Boot 3.1, this library is still vulnerable. What happens is, if I'm doing the normal way of deserializing and serializing YAML to a YAML file, I can do something like you have this weird thing, which basically points to whatever object it was in my system. I can misuse that. For instance, what I can do is, if I going back to this, I can again call basically any object in my system and give it an arbitrary command, open my calculator. Well, let's try that. So if I import a YAML file and gadget.yaml that I showed you, open it and submit it, boom! Because by default, YAML also goes back to object and then tries to parse it, tries to cast it to an object. The newer version of YAML, Snake YAML 2.0 or 2.1, already prevents that you now can only, by default, serialize objects that are primaries. But in Spring 3.1, it's still an issue. This is there. Hopefully, you're not using YAML in this way, but if you accept YAML from an outside source like a user, you might be in trouble as well, because this is possible. Well, I can show you something with XML, but that's old, and I only have 1.5 minutes left. Let's try it. My orders. I can export to XML as well, fine. But one of the things I can do is, if I look at an XML file, I can also do some weird stuff, weird shit, I would say, with XML. One of the things is this. This is valid XML. I can do external entity injections. Basically, I'm saying, hey, I'm using doc types and external entities, which is a feature in YAML, in XML. And normally that is to go to DTD files to make sure that that your XML is validated. But now I point it to a file on my file system. And instead of the product name, I just refer to this. By default, all XML parsers in the JDK are vulnerable to this because this is considered a feature. Yeah, that's what I call my bugs as well. So if I import this thing, this XML file, what we'll see is that as part of the output, you now see the content of my passwd file, which I normally do not want to show to my existing users. So you can now disclose stuff that you do not want to disclose to your to the outside world. Yes, you specifically need to unmark external entities to make sure that this is not working. If you want to know about that, I have some information for you later. So let's wrap this up. First of all, do not deserialize input from unknown sources. Obvious, but unfortunately sometimes we need to do that. Next, prevent Java's custom serialization as much as possible. Okay, but sometimes we need to. If so, use filters, like I showed you with either the Apache Commons I/O or the JEP 290 and JEP 415 to use filters to explicitly point which classes you do want to deserialize. If you're using other sorts of serialization like JSON, XML, and YAML, make sure that you know how these marshals work and not just copy whatever ChatGPT or Stack Overflow say, because they're just as bad. Check for defaults. How are defaults set? JSON, Jackson library, the defaults are great. The YAML library, Snake YAML, not so much, as the ones that are delivered with Spring Boot for you. The newer versions are already better, but they're not integrated in Spring Boot 3 yet, but hopefully it will be. So check for these defaults and how it's used. Some of these defaults are insecure. Be aware of that. And last but not least, update these insecure libraries by scanning your applications to see what kind of libraries you're bringing in. And if there are problems with that, and of course Sneak can do that for you, scan it, check it, update it, so you're at least at the latest version, because most open source maintainers try to update their libraries frequently. I'm actually out of time already, so let's keep it to this. Hope this was useful. Thank you.